Hello, Namaskar. Today we'll be discuss on topic pattern types, materials, and analysis. Pattern. The pattern is the principal tool during the casting process. It is a replica of the object to be made by casting process with some modifications. The main modifications are addition of pattern allowances and the provision of core print. Casting is to be hollow, adding a pattern called core are used to create the cavity in finished product. The quality of casting product depends upon the material of the patterns, its designs and construction. The cost of pattern and related equipment are reflected in cost of castings. The use of expensive pattern is justified when quantity of casting required is substantial. Pattern types of pattern. There are major three types of patterns are available. First one is solid or single piece pattern. Second one is split or two piece pattern. And third one is match plate patterns. You can see all three types of patterns in this first figure, and two remaining figures belongs to casting and require provision in building boxes. The types of pattern: single piece pattern, split or two piece pattern. Patterns of various types, each satisfying certain casting requirements. Single solid piece pattern. The one piece or single piece is most inexpensive of all type of pattern. This type of pattern is used only in cases where job is very simple and does not create any withdrawal problem. It is also used for application in very small scale production or in prototype development. This type of pattern is expected to be entirely intact and one of surface is expected to be flat, which is used as parting plane. The plating system is made in mold by cutting sand with the help of sanding tool. If no such or flat surface exists, the mold becomes complicated as typical one-piece pattern shown in figure. Next slide. Split or two-piece pattern. Split or two-piece pattern is most widely used as pattern of intricate casting. It is split along parting line. The position of which is determined by the shape of casting. One half of pattern in mold, the other half in core. The two halves of the pattern must be aligned properly when making use of dowel pin, which are fitted to half of patterns. The dowel pins match with precisely made hole in the half of patterns. You can see in the below left figure. The typical split pattern of casting wheel is shown middle figure, or match plate patterns also you can see uh, bottom right side third figure. Function of pattern. The pattern prepare a mold cavity for purpose of making casting. A pattern may contain projections known as core print. If casting requires core need to be made hollow. Runner gates riser used for feeding molten metal in mold cavity may form a part of pattern. You can see before previous slide, and pattern properly made and having finished and smooth surface reduce casting defect. A properly constructed pattern minimizes the overall cost of casting. Pattern making. Pattern may construct from the following materials. Each material has its own identity limitation and field of applications. Some materials used for making patterns are wood, metals and alloys, plastics, plaster of Paris, plastic rubbers, wax, and resins. To be suitable for use, pattern metals should be property, easily worked, shape, joint, light in weight, strong and hard and durable, resistance to wear and abrasion, resistance to corrosion and to chemical reactions, dimensionally stable, unaffected by variation in temperature and humidity, and allowable at low cost. Next slide. Usual pattern material. The usual pattern material are wood, metal, and plastics. Metal must be soft and easily machinables. The usual pattern metals are wood, metal, and plastic. The most commonly used pattern metal is wood since it is adaptable and long weight. It also can be shaped and easily cheap. The main disadvantage of wood is it absorbs moisture which can cause distortion and dimension change. Hence, proper seasoning and upkeep of wood is almost a prerequisite large scale use of wood as pattern metal. Pattern losses is a vital feature and it affects the dimension characteristics of casting. When pattern is produced, certain allowance must be given on site, specified at finished component drawing, so that a casting with particular specific can be made. Selection of correct allowance greatly help to reduce machining costs and avoid rejections. Allowance usually consider pattern and core boxes are as follows. Linkage or construction allowance, draft and tape allowance, machining finish allowance, distortion and timber allowance, and wrapping allowance. Single contact allowance. Almost all cast metals sink or contact volumetric on cooling. The metal sinkage is two types: liquid sinkage and solid sinkage. Liquid sinkage is referred to reduction in volume when metal change from liquid state to solid state at solid temperature. To account this sinkage, the riser which feed liquid metal to casting are provided in mould. And solid sinkage is referred to reduction in volume caused when metal lose temperature in solid state. This sink allowance is provided on mould pattern. The rate of contraction with temperature depends on material. For example, steel contact on higher degree compared to aluminum. Next slide. Draft and taper allowance. Draft is means the taper provided by pattern maker on all vertical surface of pattern so that it can be removed from sand without tearing away side of the sand mold. Without excessive wrapping with molder. Below first figure show a pattern having no draft allowance being removed from pattern. In this case, till the pattern is completely left out, side will remain in contact with wall, mold and the break it. This is and machining allowance. The finish and accuracy achieved in sand casting is generally poor and therefore when casting function is required to be good face finish, yet it is generally achieved by subsequent machining. Finish allowances are therefore added in pattern dimension. Amount of machining allowance to be provided was affected by method of molding and casting size. Hand molding, machine molding, sand casting and metal mold. The amount of machine allowance is also affected by size of shape and casting. The casting orientation, metal, degree of accuracy, distortion, timber allowance. Sometimes casting get distorted during the solidifying due to their typical shapes. For example, if casting has a form of U, V, T, and L, will tend to contact at the close and causing particulate to look like flat and inclined. In this case, this can be prevented by the making a line of UV and LT shape pattern converge slightly inward, so that casting after distortion will have this side vertical. Distortion in casting may occur due to the internal stress caused on account of unequal cooling of different sections of castings and hindered contraction. Measures taken to prevent distortion casting include, and you can see two figures. First one is required shape and distorted shape and cambered patterns, required camber patterns. And second one, and bottom, casting without timber, actual casting, and pattern with cameras. Wrapping a second lance. Before withdrawal from sand mold, pattern is wrapped all around the vertical face to enlarge the mold cavity slightly, which facilitates removal. Since it enlarges the final casting made, it is desirable that the original pattern dimensions should be reduced to account for this increase. There is no sure way of qualifying this lance, slightly depend on foundry person practice involved. It is negative lance and is to be wrapped only to dimensions that are parallel to parting planes. It is ignored while casting having average size, but in large casting size, when casting required precise size, then wrapping a second allows it by making a pattern slightly smaller. And you can see in this figure, this side actual pattern size and required pattern size. Wrapping and checking allows the section of this section.